My eventual goal is to give a better visualization of the decision boundary from the previous video. Like, where does my logistic regression 3-class classifier, where does that draw the boundaries between these different species of penguins? And my strategy is going to be make a whole grid of points in this range here, like from 32 to 60 and from 13 to 22, and to color all of those points, not just the points that correspond to actual penguins. So how can I do that? Well, let's import NumPy. And let's make a NumPy array of values from 32 to 60. So let's call this x. So x equals np, and a range is the best way to do this. So we're going to go from 32 to 60, and let's go up by 0.2. And let's do the same thing for the y direction. So from 13 to 22. So y equals np.arange. From 13 to 22, go up by 0.2. I was trying to decide if it would be better to have the same number of points in both directions, but I think there are pros and cons to both. Okay, great. So now what do I want? I mean, I could try making, for example, a data frame using this. So I don't think I actually have pandas imported, so let's import pandas at the same time as NumPy. And so let's try pd.dataframe. And I'm going to use a dictionary here. The x column is going to be these x points, and the y column is going to be the y points. And can you predict what's going to happen here? This doesn't work because there are different numbers of points inside of here. So that doesn't work. So what I want to do instead is I want to take, let me just show you what these x and y's look like. So there's x, there's y, and I want to take the Cartesian product of these two things. So I want 32, 13, 32, 13.2, 32, 13.4, all the way down to 59.8, 21.8. So how would you do that? One way is with nested for loops. That's probably the first way I thought of. But in general, let's try to avoid for loops in this class and when we're using Python as much as we can. So there's a nice built-in way that almost gets us this directly using NumPy, and it's something called meshgrid. So let me say np.meshgrid. And this is going to take x and y as my inputs, and it's going to give two different outputs, xx and yy, I'm going to call them. So let me show you what xx looks like. So it's a little strange, but let me show you what the shape is of xx. And let's see, let me keep it visualized up here. So it's 45 by 140. What do those numbers mean? Well, let's see, can I just do size? What's the size of x? It's 140. So each of, how many columns are there in this NumPy array? There are 140 columns, and there's one column for each value in x. Okay, and then if I look at what's the size of y, okay, it's 45. So there's one value for each of these, there's one y value for each row in xx. So let me display these next to each other. Here's yy. So here for xx, it's constant along the columns. For yy, it's constant along the rows. You can imagine that if we were to smush these together, whatever I mean by that, then I would have this Cartesian product. I would have 32 together with 13. I would have 32.2 together with 13, and so on. So how can I do that? Well, I'm actually going to do a different step in between. So I'm first going to just get rid of that two-dimensionality. So I'm going to reshape. And remember, this -1 says, I'm not telling you how long it's supposed to be, just put it all into one axis. Okay, great. And then yy.reshape will look similar, just some, not a like array of arrays, but just a single. Actually, that's probably the wrong way to say it, but not a two-dimensional array, but a one-dimensional array here. And so what is good about this? Well, what's the size of this going to be? And this should be exactly the size of x times the size of y. Okay, and that's also like, what set is that the cardinality of? It's the cardinality of the Cartesian product of x with y. Okay, great. And so let's put these into a data frame. Let's call it dfsim, because this is like simulated data. And this is going to be pd.dataframe. Okay, now what I was trying to do before, the x column is going to be this xx.reshape -1. And the y column is going to be this yy.reshape -1. Okay, and let's look at this dfsim. And so here, like aside from some numerical precision things, like where this says, gotten off a little bit by some 6 times 10 to a big negative number. Other than that, this is exactly that Cartesian product I wanted, 32 by 13. 32.2 by 13. And if I look at the tail of this, okay, this is the end, goes down to 59.8 by 21.8. Okay, and we will use this data frame in a later video to actually try to better visualize this decision boundary that's made by the 3-class classifier for these penguin species that we made in the last video.